Hello everyone, myself Satadal Neogi, Assistant Professor in Civil Engineering Department, Mallabhum Institute of Technology, Vishnupur. Today, a topic from structural analysis which is a static indeterminacy will be briefly discussed. Before going into the static indeterminacy, we have to first know what is indeterminacy. So, if the number of unknown reactions are more than the number of equilibrium equations available in the structure, then the structure is called indeterminate structure. And when you talk about equilibrium equations for 2D structure are 3 in total. Those are sum of the forces acting x direction will be 0, that is sigma fx equal to 0, and sum of the forces acting y direction will be 0, that is sigma fy equal to 0, and sum of the moments also will be 0. And likewise, equilibrium equation for 3D structures are 6 in total. And when you're talking about finding static indeterminacy, we can do that by adding external indeterminacy and internal indeterminacy. External indeterminacy deals with the number of unknown support reactions in excess of available equilibrium equation, and internal indeterminacy deals with the internal reactions or forces in excess of equilibrium equation. Static indeterminacy for 2D structures we can find out by the formula. What will be the notations? M equal to number of members, and R will be number of reactions, and J will be number of joints, and alpha will be number of releases. Number of releases will come into the action when there is a hinge in the structure. And when talking about the formula is written Y3M, because in any member of 2D structure there are 3 internal forces, and Y3J because for 2D structure there are 3 equilibrium equation. So when the structural indeterminacy is less than 0, then the structure is called unstable, and when structural indeterminacy is equal to 0, then the structure is called determinate, and when structural indeterminacy comes more than the 0, then the structure is called indeterminate. Today we will see 2 examples regarding static indeterminacy. In the first example, we can see there is a continuous beam with 4 supports, out of which 2 are hinge support and 2 are roller support, and there are 3 members and 4 joints. When you talking about hinge support, for hinge support there are 2 reactions, and for roller support there is only 1 reaction. So if we put all the values in the formula, we can find out the static indeterminacy comes out as 3. And to mention the alpha value will be 0 because there is no hinge in the structure. So the degree of indeterminacy of this beam comes out as 3. That means the structure is statically indeterminate with 3 degree. Moving on to the next example, we can see there is a 2D frame structure with 2 fixed supports, and for fixed supports we have 3 reactions. There are 2 fixed supports, then the total reactions will be 6 for this structure. And we can also see there are total 6 members and total 6 joints, and there is also an internal hinge in the structure. So we will have alpha value. Alpha value will be total number of members joining at the hinge minus 1. In this case, total number of members joining at the internal hinge are 2. So 2 minus 1, that will be 1. So all the values if we put in the formula, we can find out the degree of indeterminacy comes out as 5. That means this frame structure is statically indeterminate by 5 degrees. And that will be all for today. Thank you.